questions on the homework. So, what we're looking at today is equations of lines. Equations of lines. Now, how many points do we need to make a line? And the correct answer is not 0. We need 2. Because if we have 2 points, we can make a line. Now, there's 3 ways that we can write the equation of a line. The first is slope-intercept form. Anybody know why we call it slope-intercept form? It's kind of dumb. Because y and x are our independent and dependent variables, our input-output. So the only two other pieces of this equation are m and b. M is the slope, b is the y-intercept. So that is up there at the top of your notes. So we called it slope-intercept form because the main 2 parts of it, it has the slope, it has a y-intercept. Slope and an intercept. So we call it slope-intercept form. I don't think we could have named it more of what it is than that. And this is very helpful, very useful if we know the slope and the y-intercept, where it crosses the y-axis. The second equation, point-slope form. Well, again, we have m for our slope. That gets us the slope part of slope point form. x1, y1 is a point. So we call it slope point form. Yeah. You can write those on your notes. They are also right there at the top. The only one that's not up there. There you go. The only other thing that's not listed is slope formula. Now, I'm going to write it one way. Delta y over delta x. Delta y over delta x. If you want to use either one of those pencils next to it, go for it. If it's not sharpening. Delta y over delta x. I have a feeling that they refer to it that way, delta y over delta x, for slope. And we don't normally use it over here, but delta in mathematics just means change. So we say delta y over delta x, change in y over the change in x. Or as the way we're used to seeing it, y2 minus y1 over x2 minus x1. Change in y over the change in x. That's all that's saying. That's our slope. Our formula for slope. Now the last one that they have given 2 points, I would do it exactly as they say it there. First find the slope, the value for m, and then plug in a point, one of the 2 points, in the slope point form. Now there is such thing as 2-point form. Don't write that down. Because we would plug in one of the points for x1, y1 in all the x1, y1 spots. Then we'd plug the other point into y2, x2. Simplify down. Really, all we did was take slope, that m, and plug it in. We took the point slope form and plugged in the equation for slope to try to get to it. Really, I think that's just way too much going on. We can just find slope, use point, slope, and go from there. 2-point form is, I think, a little unnecessary. All right. The graph shows the distance asteroid 2012 DA14 travels in x seconds. Write an equation of a line and interpret the slope. The asteroid came within 17,200 miles of Earth in February 2013. About how long does it take the asteroid to travel that distance? So, several things it's wanting us to do. Why not? Let's get a highlighter. One, it wants us to write an equation of a line. Two, it wants us to interpret the slope. And three, it wants us to know how long does it take the asteroid to travel 17,200 miles. You don't have to highlight all that. I'm highlighting it just, this is what we're doing. We're answering three main questions. We're going to have to do four things at least, but we're answering three main questions. Let's throw that on the floor. Write an equation of a line, interpret the slope. Well, the first thing we're going to need to find is the slope of the line. Now, they did give us a graph here, and they did tell us one of the points, 25, 24. 24 is our y, 5 is our x. Did they tell us another point? Not directly, they didn't give it to us like the 524, but there is another nice intersection on that graph. It's down here at 0, 0. So the other point that we do have is 0, 0. Now we can calculate this from here. 24 minus 0 is, 5 minus 0 is, will this reduce? Well, no. 24 over 5. Now the other way we could have done this, we could have taken a calculator and said 24 minus 0 over 5 minus 0, 24 over 5. It doesn't reduce. So our slope for this here is 24 over 5. Questions on how we found the slope? Now it does ask us to interpret the slope. What that means is we take whatever the slope is and turn it into words. We're trying to describe what the slope is telling us. So change in y over change in x. So the x values correspond to what? X values correspond to time. The y value corresponds to distance in miles. So one way we can say this and interpret it is for every 5 seconds, it travels 24 miles. For every 5 seconds it travels, the asteroid travels 24 miles. Now, that's not the only way we have to write this. I'm just writing this above it because that's what we're answering. We're interpreting the slope. For every 5 seconds, it travels 24 miles. It travels 24 miles every 5 seconds. Is that a different way to say it? No, we just flipped it, right? I'm going to tell the calculator to approximate. So 24 over 5 is the same as 4.8, yes? Because 4.8 is now over 1, so we're saying not for every 5 seconds, but we're saying for every second, 1 second, it travels 4.8 miles. Questions on this here? Do I need both of these? No. You just need to give me one of them. You need to give me a way. You're just taking what the slope is and turning it into words. Okay? There's more than one way to write it. There's more than one way to list it. As long as what you say, and again on the homework, what you write matches the slope, I will take it. Okay? You're good. So we interpreted the slope, yes? Is there anything else we need to do? We need to write the equation of the line and then see how long it takes the asteroid to travel 17,200 miles. So we have two other things to do. So for writing the equation of the line, we have two equations we can use. Y equals mx plus b, and our y minus y1 equals m times x minus x1. We have these two ways to write the equation of the line. Now the question and the big determining factor between which one we pick is, do we know the y-intercept? Do we know where it crosses the y-axis? Because when we cross the y-axis, the y-intercept, this here is going to be the point 0, comma, b. Do we have that point on this graph? Well, yes, 0, 0, which tells me slope-intercept form is going to work nicely because we know that the slope is 24/5. The value of b is 0. It's the y value at the y-intercept. So we could take these values and plug them in, telling us that y equals 24/5 x plus 0. We can simplify this to just 24/5 x. So we found our slope. We interpreted it. We said what it is. Since we had the y-intercept, we can use slope-intercept form to find the equation of the line. And the last thing we had to do was what? Determine how much time it would take to travel 17,200 miles. Yes? Distance in this equation, and we can use this equation. Is distance variable? Is it x or y? Which variable responds or is in correspondence with distance? Is it the x-axis? It's the y-axis, yes? So that means we can plug that 17,200, not 2,000, 200 in for y. And now we need to solve for x, yes? Well, we need to get the x by itself. What can we do to get x by itself? Yes, sir.
Minus 17,200.
Yes.
Then, divided 24 over 5.
Yes. We would divide both sides by 24 over 5. Because the 24 over 5 divided by itself is 1. Now we need to figure out what 17,200 divided by 24/5 is. And the nice thing is, well, 17,200 miles divided by 24/5 is approximately 3,583. And that'd be 3,583 seconds. Which, if we converted this to hours, it didn't ask for it. This is what it was asking for. It'd be approximately 1 hour. Any questions on this here? We kind of get this here. Yes. And we understand that that is insanely fast, right? 4954. So, picked a, well, random but not random. The distance from here, I picked Berlin, just mainly because since you're here, might as well pick another country. Germany, which it says the distance from here to there is 4,954 miles from one to the other. And traveling at this speed, we can get from here to there in 1,032 seconds. If we divide that by 60, that would turn it into minutes, so 17 minutes. So traveling at this speed, we can get from here to Berlin faster than this hour. Actually, the amount of time it's taken for us to do this lesson so far, we could have made it to Germany, traveling at this speed. As you know, it does not take, it takes way longer than that. So this is really fast, how fast this asteroid is traveling. Okay, questions on this here? Because again, what we're doing is just finding equations of lines and interpreting what it's telling us. So if we look at this next one here, the graph shows the remaining balance Y on a car loan after making X monthly payments. Write an equation of the line. So there's one piece. We're going to write an equation of the line and interpret the slope and y-intercept. So here we're interpreting two things. And we want to determine the remaining balance after 36 payments. So the first thing it might be good to find is the slope. So it might be good to find more than one point. So what points do we have? We have these two here, yes? So what's one of our x value or y values that we can use? Well, we could use what? Pick one of them. 18, yes? Minus the other y value would be 15. Now, when we plug this in, the corresponding x value to 18 is 0. Corresponding x value for 15 is 10. We just have to make sure those corresponding values line up. Now, 18 minus 15 is 3. 0 minus 10 is negative 10. Three over negative 10, we could say negative 3 over 10. I like putting the negative on top or in front of it. I don't like leaving it on the bottom of the fraction. Questions on how we found this here? Now we're going to go on and interpret the slope. So the x value is the number of payments. So for this here, our 10 is saying for every 10 payments, the balance does what? Goes down, decreases. Goes down by how much? $3, yes? That doesn't seem quite right, because it feels like it should be more than that, yes? Well, let's see what the chart told us. Because it is balanced in what? Thousands of dollars, yes? So the amount, the balance is going down by 3, but it's actually what? 3,000. Now, the reason they do it this way and they don't list it as 3,000 or 18,000, 12,000, 6,000 is that it makes the graph easier to look at. It makes it, we scale it so it is easier to work with, easier to look at and see. Because otherwise our scale would be really big. Now the other thing we need to interpret is the y-intercept. Now the y-intercept was told to us is 0.18, yes? So at 0 payments, it's saying we are at 18 or 18,000, yes? So what is this y-intercept telling us? It's telling us what? The starting balance, the original balance, is $18,000. So before we start making payments, we owe $18,000 on the car. Really? Where I was looking up the distance, apparently an ad popped up. Get rid of that, Sam. Questions on interpreting the slope and the y-intercept? I feel good with this here. Yes? Now, we do need to find the equation of the line. Now, they did give us the y-intercept. So since they gave us the y-intercept, we know what the y-intercept is. We can use y equals mx plus b. Because our slope is -3/10. Our b value, the y-intercept is what? 18. Because the b is the y value at the y-intercept. And the y value at the y-intercept is 18. So that tells us the equation is y equals -3/10 x plus 18. Questions on this here before we answer the last part? We go with this here. So the last thing we have to do is find the remaining balance. Well, our balance is y, yes? Number of payments is x. So all we need to do is plug in 36 for x. So when we plug 36 in for x, it'll tell us the number or the remaining balance. Now we can multiply this out and do this by hand, and I'll do that here, but is there any variables left on this right side? Is there anything telling us we can't just take this and plug all that into the calculator? No, we can plug that entire side into the calculator and let it do it for us. So we can say negative 3 tenths times 36 plus 18 is 36 fifths, or 7.2. Now 7.2 is our remaining balance in what? Thousands of dollars. So really the remaining balance is 7,200. So the remaining balance after 36 payments is $7,200. Questions on this here? Questions on anything we've done so far? The graph shows the distance Allison hikes in X hours. Write an equation of the line and interpret the slope. How long does it take Allison to travel 14 miles, traveling at the same rate? A few things we need to find. One, we need to write an equation of the line. We need to interpret the slope, and then see how long it takes her to travel 14 miles. So again, slope. y2 minus y1 over x2 minus x1. Now our y values, because they did give us the point 7, comma 24.5, yes? So one of the y values is going to be 24.5 minus its corresponding x value is 7. What's another y value they gave us? 0, 0, yes? Now we can subtract it like we did before, giving us 24.5 over 7. Now, unlike the last one, the first one we did like this here, we can't leave it as 24.5 over 7. We cannot have decimals and fractions in the same spot. It just doesn't work that way. And there are methods for us to simplify this. We can plug it in the calculator. It tells us it's 3/5 or 3.5 or 7/2. For the most part, I will write slope as a fraction because it is sometimes easier to read. Because what we're saying, for every 2 hours, she's traveling 7 miles, or for every hour, she's traveling 3.5 miles. Either one of these works for the slope. Now, for our interpretation of the slope, we kind of I already said it. For every 2 hours, she travels 7 miles. We interpreted the slope. Questions on how we did this here? Now for this one here, I'm going to use point slope. Now, yes, we could use point slope form or slope intercept form because we do have the y-intercept, we do have the slope. Let's just say we use this here. Well, our y1 we can say is 24.5. Our slope for this here we'll say is 7/2. Minus our x1 is 7. Questions on how we plug this in? Now we do need to get the y value by itself, so we'll distribute the 7/2. So we still have y minus 24.5. 7/2 times x is 7/2 x. Now we do need to do 7/2 times -7. So -7 times 7/2 is -49/2 or -24.5. Last thing we need to do to get y by itself is to add 24.5 to both sides. Minus y is equal to 7/2 x or 3.5x. So it is possible to use point slope for this here, but it would have probably been a little bit quicker to just use y-intercept. Because we plug in the slope of 7/2, the y-intercept of 0, giving us 7/2 x. We found the equation. Now the last thing we need to do is figure out how long it takes her to travel 14 miles. Now just like the first problem, our y value is our miles. And again, just like before, we'll divide both sides by 7/2. So 7/2 and 7/2 will cancel, giving us x. 14 divided by 7/2 is, so it takes 4 hours for her to travel 14 miles. Questions on this here? Questions on anything we've done so far? We'll stop there for today.